Hello everyone, I'm Sudong Cai from Computer Vision Lab, Kyoto University. I'm very glad to introduce my research about neural feature activation. The choice of activation model is decisive in neural feature learning. Basic methods are inspired by neuronal behaviors, and based on them, past efforts have made significant progress. We instead propose to explain activation from multi-criteria decision making, find unaddressed problems, and present IIU as a novel solution. As a key idea, we treat a nonlinear activation model as a selective recalibrator that rectifies features according to their importance. Such importance is first modeled by the feature filter in a product, which supposes to indicate a similarity. However, differentiated norms possibly bias these similarities, thus likely interfering with the estimation of actual feature importance. We identify this as a critical yet unstudied problem, namely mismatched feature scoring. Here we first formalize the basic notations which helps to clarify our idea. For a given explicit activation function phi, we can rewrite it as follows. That is, rho is the derivative function of phi, which is squared to recalibrate features. We rethink nonlinearity from MCDM. Although indispensable, the mathematically absolute nonlinearity can also be brought by other basic operations like normalization layers and biases. Then why nonlinear activation is still necessary? As a possible explanation, non-important features are possibly scored with negative inner products and deteriorates the learning. These necessities are selective recalibration, or so-called activation. We bridge nonlinearity to selectivity and argue that nonlinearity is necessary but insufficient for activation, and further intuitions for concrete selectivity is required. As discussed, feature filter inner products are non-biased, since they are related to the learning of previous layers and initializations. That is, inner products do not exactly measure the current feature importance. We then assume that there exists an ideal feature filter similarity measure rho, and our goal is to propose a suitable approximated similarity as rho can be excessively difficult to find. In particular, typical activation models apply the inner products as the approximate similarities, such that the mismatched feature scoring problem is left unsolved. We propose IIU as the initial solution. The key can be summarized as norm decoupling for features and filters to address the mismatched feature scoring. The IIU prototype is composed of three core ingredients. That is the norm decoupled similarity term, the auxiliary bias term nu to incorporate further learning flexibility, and the adjusted function y sigma that provides oriented adjustments. The details can be found in section 2. So figure D and E draw the spirit of IIU, and to introduce practical methods for applications, our main goal is to embody the bias term and the adjusted function. Here, IUB is our basic solution. It learns the auxiliary bias with only layer norm and positive constraint using sigmoid, which brings only negligible additional computational cost. We propose a simple adjuster function tailored to our assumptions. The details can be found in the subsection practical method. Here we introduce IIU dynamic coupler based on IUB. The key is to estimate the combinational weights for the main and shortcut features by extending the channel attention from a single side weights without contextual cues of residues to the double side weights estimation that exploits dual context cues interactively. We validate our IIUs on 4 vision benchmarks of 3 different tasks. Here we show the results on ImageNet with ResNet backbones. We compare IIUs with the relevant baseline, the popular activation functions, and the current sorters, where our methods enjoy significant improvements. On lightweight backbones, we find our methods show consistent improvements. Here we show the accuracy and loss curves to demonstrate the convergence attributes, where IEUs not only reach the highest accuracies, but also show superior convergence attributes of optimization to the compared activation models. More detailed results can be found in the paper. Here we summarize our conclusions as threefold. We propose to interpret neural feature activation from the new view of multi-criteria decision making, and we identify the critical yet unsettled problem, mismatched feature scoring, and present IIU as the initial solution. Then we validate IIUs through comprehensive analysis and evaluations and report significant improvements on sorters. Sincerely, thank you for your patience.